All right, means of samples video 2. So what we're trying to do is show that the group that I impacted, the group that I changed something with, or that I proposed that they change something using the app, walking your dog, whatever, had a significant change, a significant difference that I wouldn't expect to find just by coincidence or chance from my general population. Okay. Now, the problem is, let's go back to the meditation app example and let's put it in the context that we've talked about, like test scores. Let's say I find 100 students at Drury who have said, I have an issue with anxiety related insomnia. And I choose 25 of those students to try my new meditation app and see if it helps with their insomnia. If I plot the scores of everybody, right, to try to do the Z-scores and see if there's a difference, what do I do about the fact that there's 25 students that tried out this app? Do I plot all 25 of them, evaluate each of their Z-scores, and then give this complicated write-up of 18 out of the 25 showed a reduction, this percentage was this much? It's like, it could get very complicated. And I'm using a small number, right? 25 students, 100 students. What if I went up to Mizzou and did this with 1,000 students, right? What if I got funding to do a wide-scale sleep study and had 3,000 participants? Trying to do individual scores would get overly complicated very quickly, and there wouldn't be a way to write it up in a meaningful way. This is where means of samples comes in. Now, I can't just take the average of my 25 students and compare it to everyone else's individual scores, because as your book says, that's comparing apples to oranges. I can't compare the mean of one group with the individual scores of another group. So I have to make some change to how I'm looking at this data to come up with a conclusion of, is my group of people significantly different? Is it falling over there in those tails where it wouldn't just be by chance? In the same way that in the textbook examples we've talked about, am I as an individual significantly different when it comes to a test score or something? So where the means of samples comes in is that I have the 100 students that were in this group. I picked my 25 that are using my app. I'm getting information about everybody about their sleep. Let's say I do show that my 25 students have better sleep quality because they're using my app. How do I know that if I would have taken other samples of 25 random students out of this group of 100, that by chance I wouldn't have pulled students who also had improved sleep for some other fluke reason, right? Because I actually did the math on this. Out of, if I'm taking groups, that's actually for a later example. Scratch that. Point is, there's a ton of possible combinations, right? Like billions of possible combinations. If I have a group of 100 and I'm randomly selecting any combination of 25, how do I know that some of them wouldn't just by chance show an improvement? This is the whole purpose of means of samples, is we're evaluating what is the chance that I would have drawn a random group out of my sample that would be showing the same results as the group that I'm actually testing. Hopefully that makes sense. Okay, that's part one of this. That is the why behind why we are doing this. Because remember, that second step of hypothesis testing that your book talked about is we're having to compare. We have to know what our comparison group looks like. We have to know their characteristics. We need to know their mean. We need to know their standard deviation. That's how we know if the group that we're trying to influence is actually having a difference, right? That's how we make our comparisons. And so with the means of samples for hypothesis testing, our unit we're looking at is no longer the individuals. Our unit we're looking at is, what if I got a group of participants and found their mean? How would that compare to my mean of interest in my group over here? We'll get part 3.